Welcome once again. In the last video, we talked about latency. And if you've not watched it, you can watch it here. But latency is simply the time it takes from one system to communicate to another system, right? And we mentioned that one of the popular causes of high latency, which you don't want, is an unoptimized database or an unoptimized database queries. So for this video, we'll just look at two options. I'm just going to ask a question now. I want to see your perspective. And then I'll share my own perspective on this. And you can leave in the comments whatever you think. There might be a better way to do this, there might be a better way to think about this. I'm still learning, using my experience to talk, but I'm still learning a lot along the way as I come up with this, right? So which approach do you think would be best? You've optimized your database. Your database schema are well optimized. So you don't have a database schema problem. But for whatever reason, you have to run a query that involves combining records or data from multiple databases, from multiple tables. So you have about 10, 15 tables that you need to combine from. For whatever reason, let's just assume there's a reason that has to be. Right? So you have like 10 tables that you need to make requests to combine. In terms of improving the performance of your system, of your application, do you run one large aggregated query, which is going to have like inner joins and left joins and right joins and complex joins? That's for SQL. If you're using regular collection, you're going to be aggregating from this to this, connected to this to this. Or do you run multiple small queries that goes to the database, fetch a record, and on the application layer, you now put them together to form the data structure you want? So let me know, just take a minute to just think about it, right? Do you run one large aggregated queries that will be combining records from the 10, 15 different databases just to form your value? Or do you run smaller scripts, like smaller queries that can just go to the database on their own and fetch the record? And in your application layer, in your backend application code, you now just put the data together in the data format you want and do some looping and you get it to work. So just take a minute to think about it. Let me know what you think. So I'm assuming you've given it some thought. If you said one large aggregated query, one of the reasons you would say that, right, is, and remember, like everything in tech is all about trade-offs. You are losing something just to gain something. Even in life, generally, most things are just about trade-off. So if you said large aggregated query, you are right and you are wrong, right? Depends on the context. Context matter. I don't mean to be cliche, but context matter. So let me look at the pros and cons of each approach. For large aggregated queries, you are lucky because you would not be making multiple trips to the database. You're just making one trip to the database. Now, if your database is in a different environment from your backend application, which it should be, you should not be putting your database in the same environment or instance as your backend application, because your backend application should be stateless. We can talk about this in another video. If you want me to talk about it, just leave a comment, and I'll talk about it later. But your application should be as stateless as possible. You should be able to restart your application and not lose data or lose the state of the application, right? So if your database is in a different state entirely, if you're unlucky, it's in a different region. Maybe your backend is in US East, is in America. Your database is in maybe UK or South Africa, right? For every request to the database, your application has to make a trip. Remember the graph I drew in the last video talking about the trips that has to be made across the network layer to your telecom. Your database has to make a trip to that. Your backend application rather has to make a trip to that database to fetch the record and get it back. Now, if you're running one large aggregated query, it makes only one trip and gets a response back. So it's fast, right? No more trouble. But if you're running multiple aggregated scripts, it has to make multiple trips to the database. So it goes one. This script makes multiple, and that goes, another goes, another goes, another goes. So in the simple sketch, you have the first guy. This is you, or the first guy. This is your backend application. This is your database. Right, this is your backend application. The first approach just makes one trip, does all the complex querying, all the inner joins on the database layer, and gets a response. Right? But the second approach, this is your server, this is your database. Second approach, multiple scripts. And each of these scripts adds their own overhead or time complexity. So you might say, oh yeah, it's very intuitive. It's the first approach. And sometimes it is the first approach. A lot of times, actually the first approach. That works. But this creates a different problem on its own. One is that large complex scripts, large aggregated scripts, actually take time to run on the database layer. Now, usually your backend has to establish a certain amount of pool. You have to create a certain amount of connection pool from your backend to the database. So for the purpose of this, I'll just say, let's say you have 10. It's quite small, but let's say you have 10 connections. The way it works is for every query you write, you use up one of those connections. So when you use up that connection, I write a query, it makes a request. There are now 9 available connections. I run on that query, there are now 8 available connections. I run on that query, there are 7 available connections like that. Once this query gets resolved, it frees up 1, so I go back to 8, right? Make sense? So what happens when you run large queries is that potentially these large queries take time to run on the database and can use up connection and not free up any connection among the pool for other people to use. So even though it seems like this query is running faster, your application is going faster, it's blocking other simpler applications from actually running. Because now they have to queue and wait for these large complex queries to be resolved. Unlike if you are this smaller, that they just pick it up, run, free it, and some other random application, some other random query somewhere can just pick it up and use it. So even though it seems like your application is faster, you are going to be blocking some other systems from running. Alternatively, if you are using the smaller approach, you have a lot of small queries, the time it takes for these queries to go and the response could add to the query time. So that particular endpoint or that particular system might take time to load, but it's not necessarily blocking the IO. So other people also have the chance to load. And if you want to over-optimize for that, you can even go ahead and make it asynchronous. So you can run each of these requests in an asynchronous way, especially if they're not dependent on one another. You run them asynchronously, and you get the data almost at the same time, and you just resolve it immediately. It depends on your particular context. Right? If you have to go with the first approach, one thing you can do, and note, this is not like, I keep saying it over and over again, like these are not hard limits. You might have a different perspective or a different experience that you want to share in the comments. Just do it for me. But one thing you can do is if you know you're going to be having a different query with or large queries with different database requirements, you can actually use a dedicated database for this, or use some even database that are tuned to operate based on this type of load. So for example, if you are storing a lot of logs, you want to use a time-based database, a time-conscious database. Right? If you are storing something that requires GraphDB, you need to use a Graph database, not just a generic database. So you pick a database that is well tuned for this particular use case, and you can easily create a dedicated database and isolate it from the rest of your system, so that whatever performance impact is had is scoped to this database, while your regular application is using a different database that just works, so it's not blocked. So then it would make sense to use this large query. So in summary, it depends on your context, especially your application, like many other things. And there's a pro of using the large aggregated query. There's a pro of using the smaller chunk query. There's a con of using large aggregated query, smaller chunk query, and there's a pro for it. Thank you. See you in the next video where I talk about another potential cause of high latency and its solution. Cheers.